Hey everyone, today I'm diving into the world of non-parametric tests. If you've ever struggled with stats, you're not alone, but stick around because non-parametric tests might just become your new best friend. So, what are non-parametric tests? Unlike parametric tests, which assume your data follows a certain distribution, non-parametric tests are more flexible. They're great when you can't make assumptions about your data's distribution. Think of them as the Swiss Army knife of statistical tests. Let's break it down. Say you're comparing two groups, but don't know if your data is normally distributed. You can use the Mann-Whitney U-test, a non-parametric alternative to the t-test. It ranks your data and compares the ranks between groups. No need to worry about normality, or imagine you're analyzing paired data, like before and after a treatment. The Wilcoxon signed rank test is your go-to. It's the non-parametric cousin of the paired t-test. Again, no distribution assumptions needed, just rank those differences. And what about more than two groups? Enter the Kruskal-Wallis test. This one's like ANOVA, but for ranked data. It's perfect when you're dealing with multiple groups and unsure about normality. So why use non-parametric tests? They're incredibly versatile and robust. They handle outliers and small sample sizes like a champ. Plus, they're super handy when your data doesn't fit the mold of traditional parametric tests. To wrap it up, non-parametric tests are powerful tools in any statistician's toolkit. Whether you're dealing with unknown distributions, outliers, or small samples, they've got you covered. Keep them in mind next time you're crunching numbers. Thanks for watching. If you found this helpful, don't forget to like and subscribe for more quick guides. See you next time.